I'm real happy to have a few speakers here to talk about the Minnehaha Stormwater Adaptation study and about NOAA's Climate Explorer tool. Let's see here if I can advance. I'd like to remind you about the association. We bring extension professionals together to discuss natural resource issues, needs, and opportunities. We advance natural resource extension through continuing education for extension professionals and promote cooperation among states, regions, agencies, associations, and businesses on natural resource education programs. If you aren't a member of ANREP yet and like to receive these benefits and others, please join. Not too expensive, and we have great conferences when we get together. Okay, here we go. Here are our speakers today. We've got Leslie Yetka, who is a program manager for an organization called Freshwater Society out of St. Paul, Minnesota. Not too long ago, she was working for University of Minnesota Extension and started a relationship here with Dr. Edward Gardiner, who goes by Ned, and he does a lot of the outreach and education for NOAA and their climate resiliency program. So I'm looking forward to hearing more of what Ned's got to share with us. He's got some great tools and hoping to be doing this next month and into next year with partnering with Ned. Okay, so Brent, at this time, I'm ready to hand the screen over to Leslie and let her talk about the Minnehaha Stormwater Adaptation Study.
All right, let me change things up. You are now a presenter, Leslie. Take it away.
Thank you. Well, thank you, everybody. And I'd like to thank ANREP, our webinar host today, this afternoon, and for inviting me to participate. And Chris was right. I did work for University Extension here in Minnesota for a while, but I'm actually here to talk about a project that I was involved in a previous position with the Minnehaha Creek Watershed District. And I was involved in this project for about 2 years, and this project actually was completed in 2013. And now I'm actually working with the Freshwater Society, which is a Minnesota nonprofit, and we are driven to protect water resources and work with others in our communities to protect water resources, not only surface water, but also groundwater sustainability. And one of the areas that I'm very interested in is actually community resilience planning, and specifically related to climate change. And part of that interest stems from the work that I was fortunate to be involved in on this project. So I'll just briefly go through the project details itself and then talk about some lessons learned. And I'm going to go pretty quickly. There is a very detailed final report on this project, which I will provide you information on how to get that. I will preface it by saying I'm not a modeler, and so I'm actually, my background's in education, and so I consider myself an educator and working in community planning and engagement. So sometimes some of this information is quite complex, and I'll do my best to convey it, but there is a report that has much more detailed information. So this project really was meant to act as a demonstration project to demonstrate advancing community level stormwater adaptation planning in non-coastal areas. And this project was funded through NOAA. The primary principal investigator was actually Antioch University, New England. And this study was really the fourth study in a series of studies that they have completed on demonstrating community adaptation planning in a coastal area in New Hampshire. So this was actually sort of trying to take some of the processes that they have been working on and apply it in a non-coastal area in the Midwest. So the study itself had 4 main components, which I will kind of walk you through very briefly. One was to actually develop downscaled precipitation data for this region that can be then used in conducting vulnerability assessment for specifically looking at stormwater infrastructure vulnerability. And the benefit of this project was that it looked at 2 communities within the watershed, and you'll see a map of this watershed. And this watershed area, which is about 181 square miles, contains 29, the borders of 29 communities, and as you can see, it includes parts of Minneapolis, so it's really focusing on the Minneapolis area and then west of that. And the 2 communities that we focused on for the study was part of the city of Minneapolis and the city of Victoria. And by doing that, it was the purpose was to look at adaptation planning in a highly urban area, such as Minneapolis, and then also more rural or growing community, such as Victoria. And the reason being is because future land use changes were included as part of that vulnerability assessment. The third step in this process or this project was to identify adaptation options and costs. And then the fourth part was actually something that was carried through this whole project, was including in public engagement in the process of engaging these communities around climate change and vulnerabilities to climate change and how to reduce our risk. So again, I'm going to go very quickly through this. The downscaling and vulnerability piece, for those of you who are interested in modeling, the CMIP-3 and CMIP-5 climate models were used, and a range of scenarios were looked at. And so basically, the purpose was to develop 3 precipitation scenarios, what we're calling optimistic, moderate, and pessimistic, for mid-21st century precipitation. And then that downscale data was applied to a surface model using EPA SWIM for these 2 community areas, looking at not only current conditions as far as development, but also full build-out. So with that information, then, the idea was to assess vulnerability and then also look at options and potential costs. So there were really 4 potential adaptation options that were examined. One is inaction, so do nothing. So, you know, what is the what would be the cost of that and the flooding that and infrastructure damage that happens. The second one was upsize pipes for both new and redevelopment. The third was infiltration-based LID, or low-impact development practices. So what is the role of low-impact development in offsetting some of the flood vulnerabilities? And then flood reduction through projects both above ground and below ground. And so that was another potential option that communities could use. And I think the important thing to remember here is that adaptation options, specifically looking at stormwater infrastructure, are very site-specific. So the idea was just to come up with some ideas of what a community could do to reduce their risk of flooding. So that last piece I want to mention was the public engagement piece. So this was a pretty extensive demonstration of a public engagement process to help improve not only the quality, the legitimacy, but also the capacity of the stakeholders that we were working with to take further action in adaptation planning. So throughout this project, we had a website, a newsletter, we hosted education forums, we identified work groups that went through a facilitated process to actually identify adaptation strategies, and then we actually reported that out through community meetings, and we hosted a regional workshop to report out those findings. And so that is just sort of a description of, a very brief description of about 2 years of public engagement and planning that we worked in these areas. So I'll talk a little bit about the results here. The downscale data that were generated for this area, I just highlighted the 10 and 100 year storm frequencies, and if you can see at the top, you'll see recent climate, which is really Atlas 14, if you're familiar with Atlas 14. We have optimistic, moderate, and pessimistic scenarios. So as you can see, the expected rainfall amount for these 2 storm frequencies is expected to increase quite significantly. And I chose these 2 because these are what are really used for design criteria when designing stormwater infrastructure in these communities. It's also worthy to note that for the moderately optimistic scenario that was developed through the downscaled modeling, really falls within the upper 95th percentile of Atlas 14, which is rooted in actual existing data. So I'll bring that up in a minute, but I think that's an important piece to remember here. So looking at vulnerability, I'm going to go through this again very quickly. The vulnerability assessment for both of these communities showed, and it probably can be expected, that both in Victoria, the city of Victoria, which is a suburban community, and the city of Minneapolis currently have undersized pipes, and that is expected to be exacerbated as rainfall depths continue to increase. So you can just see through this graph that there is the expectation that more and more of the existing infrastructure will be undersized. It also tells you that there's a difference between Minneapolis and Victoria, and that's sort of an important piece because Minneapolis is that very highly urban developed community with a lot of existing and aging infrastructure, and Victoria is a much more new community that's growing, and so they've been actually have a lot of space to store their water, so their system is a bit more resilient. I wanted to show you this map. This is an example of how we communicated some of the vulnerability. This is specific to Minneapolis, and this is just showing kind of a stoplight map structure of how that vulnerability to increased flooding it increases as these different scenarios play out. So that was used as a communication tool to show stakeholders and decision makers on some of the expectations that they can expect in the future. This is briefly some of the adaptation options that were identified in the costs, and so I'm not going to walk through this, but one of the key things, and this is again pertaining just to Minneapolis, one of the key things too is that for low impact development, as you'll see on the bottom, obviously low impact development practices are not entirely designed to handle large flooding, so as storm amounts increase, they become less and less effective. Not that they're not important, certainly when it comes to water quality issues, but that was sort of an interesting story because often we ask the question of what's the role in low impact development, and this isn't to say that it has no role, but we have to be realistic about what that role is. The public engagement process, we again engaged many stakeholders. These were some of the stakeholders that we did have come to our workshops and actually form work groups, and we had 4 focus areas: education and outreach, land use planning, stormwater infrastructure, obviously, and funding was an issue. So the purpose of this engagement piece was to not only educate local stakeholders, but also to take them through sort of a facilitated inquiry process and understanding what kind of hazards are we experiencing now, what can we expect more of in the future, and what sort of that risk is to our communities. And the third is about what are we willing to do about it. And that's really where we got into identifying some specific strategies that are prioritized and then developing some action plans. And this is just an example of an action plan that came out of a work group related to stormwater infrastructure. So it just sort of gives you an idea of, through facilitated planning, what kind of strategies can come out of that. And then the idea is that this would then be taken by a community and actually implemented as part of their resilience planning. So briefly, some lessons learned for this project, and I'm not going to walk through all of this. It's a lot of text, I realize. But obviously, the predictions show that precipitation amounts are going to increase, and so there's certainly going to be happening. Stronger storms that are more frequent, which is what we're experiencing now, are going to continue. So that was one of our main messages. The systems that we already have in place and communities, they're already undersized because we have seen changes here, and that we have every expectation that will continue. Both in Minneapolis and Victoria, as I mentioned, we chose those 2 communities because they're at different levels of development. Minneapolis has a flooding and can expect more flooding. Victoria has actually done a pretty good job of building resilience into their system. They've been building their stormwater infrastructure to handle larger events, so in our scenario analysis and looking at vulnerability, there was the expectation that they would actually are sitting in a pretty good position, so they want to make sure they keep their policies in place and keep doing what they're doing. Low impact development was certainly something that was interesting to look at, and I talked through some of those results. Another piece I really want to hone in on, though, is the public engagement process is extremely important in adaptation planning, and we found that, but it has to be very local and actionable. And that is one of the lessons learned from this project, is that we were looking specifically at 2 communities when it came to vulnerability and identifying some of the options they may have to increase resilience. Yet the work that was happening and the people who were coming together, we were looking at a much broader kind of area, and even a regional area. So the results of that planning, while valuable, it was not always actionable by local communities. And so that's also explained in the report if you want to know more about that. So some of the next steps, a planning guide was actually produced, aside from the final report, by Minnehaha Creek Watershed District. And so that is something that's available to the public and on their website. The other thing is that the cities now here in the metro area are all going through a comprehensive plan revision, and they have to have those complete by 2018, actually. And for the first time, there's actually a chapter now that's included on community resilience. So this is a really, really great time to be talking to communities about adaptation planning and community resilience. And in fact, my work here now with Freshwater, we're actually working with communities on resilience planning specific to climate change. So that's an exciting sort of output of the work that happened in this first study, because in some ways we're replicating the process that we used. The other piece of that is that the data, some of that downscale data, is being used in a way to develop revised 100-year floodplains in relation to watersheds, and not specifically in the Minnehaha Creek watershed, but in another watershed. And that's, I think, the first time some of that downscale data is actually being used in a vulnerability assessment, which is exciting. So I want to end, I realize that was a brief description of that project, and again, I encourage you to find out more about it. But I wanted to end on sort of what's this role of extension in adaptation planning, because that's a question I asked myself too when I was with Extension. And this is just some researchers' project, actually a report that just came out recently through Antioch and their Center for Climate Preparedness and Community Resilience. And it's called the Local Solutions Report. And they actually have been evaluating communities and local needs to aid in adaptation planning. And one thing that they did find was that those communities who have not begun adaptation planning, for the most part, as you can see on the left graph, they are not collaborating with institutions of higher learning, Extension obviously being part of that. But those who are collaborating have a pretty strong collaboration, or I should say those who are adapting should have a pretty strong collaboration with higher education institutions. And as you can see, that rises to about 44%. And I think this just really highlights the fact that Extension and academic institutions can bring a lot to bear in this process as far as meeting needs of local communities. You know, they've got data, they can facilitate public planning, provide education, write grants. And so I think there's still a lot of work that can be done there, but I think that's an exciting opportunity and kind of highlights what the role of Extension can be in adaptation planning. So I know I'm out of time, but I just wanted to highlight a couple of websites that you can jot down. The MinnehahaCreek.org website actually has the final report for this project, and also a community adaptation planning guide that they've developed based on the project. And then there's the toolkit at .climate.gov, which you're going to hear about in just a minute. This project is actually showcased as a case study. It's one of many of case studies, but it is within that, that online web tool. So I think you might see that in a minute. And then if you're interested in this local solutions report, the communityresilienccenter.org has that information, and that's again through Antioch University. And so that might be of interest, especially for extension professionals, if you're interested in finding about some of their research and evaluation in the role that extension plays in that. So with that, thank you.
Thank you very much, Leslie. Hey, Brent, why don't you give me the screen for just a moment before we transfer over to Ned. And I want to encourage people at this time to, whoops, I don't want that. Here we go. You guys, okay. For some reason, okay, let's just do it this way.
What are you looking for, Chris?
The agenda here, and it seems like it's you know.
It looks like that's the agenda right there. Yeah.
Okay, but when I do full screen,
Oh, that's very peculiar.
it's not there. Oh well, we can see it that way. Please type your go to that chat button on your whatever that window is that we have for our webinar service, and in that chat section, type in some questions you have for Leslie. I think this Minnehaha Creek study just really shows a good success story of how working with extension and working with these scenarios for coming up with ways that communities can deal with what we're expecting with climate change and heavier rainfalls to adapt and be ready for the flood. So I think it's a great opportunity, or flooding, not flood. Okay, at this time I'm going to introduce you to Dr. Ned Gardiner, and I don't know if you had a chance to see Ned's little biography that I think we sent out in a few emails, but he's got a great background in landscape ecology, and then interested in public engagement. Says he's been working with NOAA the past 8 years to develop this U.S. climate resilience toolkit. And I think for us as extension educators, we've got a great tool here. And so I'm happy to be partnering with Ned to start getting an opportunity for him to share some of these the tools that are in the toolkit and exposing us to it, and we can start making better use of it in our jobs. So Ned, let's go ahead and hand the screen over to you.
Thanks, Chris, and thanks, Leslie. That was awesome. I agree. That is a really prime example of the kind of resilience planning that we want people to adopt and use. And I think the number of steps that you went through is really quite remarkable for looking at your risks and options and costs, and then evaluating next steps. As you pointed out, we do have your case study in the toolkit. So if people come to toolkit.climate.gov, they'd be able to find it by going down, viewing all case studies, by clicking case studies. And if you view all case studies, you can just look for ones that say deal with extreme precipitation by filtering on that topic and going to the Midwest. We can find the Minnehaha watershed protection case study right here. And right off the bat, if you come to this, you're doing several things that are really integral to how I think our mission is aligned with you as extension educators, as extension people with a focus on bringing science to the public. First and foremost, we teach by example. So Leslie and her colleagues provide us a really rich set of experiences to learn from and benchmark other activities in other regions of the country. And then from that context, you can find tools that are relevant for their analysis. You can find background information about water and flooding, water supply issues, as well as the deeper resources that she referred to, full list of partners who helped that work come about, and data sets that are integral to understanding the issues that she highlighted. So if you understand the context of the work she's doing and want to apply it right away, you can jump into her case study on the toolkit and begin using it. But if you don't have that background, we also provide a way to onboard you, which is giving you some of the framing that Leslie knows so well from her own experience. But you, if you're doing climate resilience for the first time, you might want some guidance. And so we have 5 steps, and we start with exploring the climate hazards and their relationship to the assets you care about. And that really gets down to understanding, you know, did you know that a certain set of issues were important where you live and with the assets that are important to you? Then we move on and ask people to spend really a lot of time, the bulk of their time, on assessing vulnerability and risk. And once that's done well, the rest of the steps really follow quickly from there. This is really determining what do you really care about, what do you want to protect, and why. And from there, you can look at your options, prioritize, and take action. That's really what can people do. So today, I'm going to focus on using some of the tools we've developed for that step 1 that I just mentioned, exploring climate threats and their relationship to hazards that are to assets that you care about. So moving on, so kind of backing out from this case study, we're really starting with step 1 and launching into an understanding of flooding. Notice that we do have vetted resources that give you some background information about the state of knowledge nationally about flooding and precipitation issues that are impacting the United States right now. A lot of this information is from the National Climate Assessment. This one happens to be from Chapter 2 about the changing nature of water resources around the country. These summaries then link out to case studies and tools. If you're ready to jump in and start understanding what are some of the local impacts of climate that has been observed or that is changing, you might, you know, from our homepage, go straight to exploring climate in your location, and you'll see 2 choices. You can launch our Climate Explorer or the legacy version of our Climate Explorer. You can learn more about this tool by going to our information page here. So this context is available to you online all the time. I don't need to spend any time right now, but if you did launch the Climate Explorer and go to the Minnehaha watershed, we could focus in on a region of Minnehaha Creek that Leslie was just speaking about. In fact, why don't I invite Leslie to give us a little more orientation to what we're looking at here. This is, I've zoomed it. Let me, I'm going to back out the zoom level so people can see where we are. Here's Minneapolis, and I'll zoom back in, and you can just maybe use your mouse, Leslie, to orient us to what we're looking at.
Sure. If you, when you were zoomed out, you could see the city of Minneapolis, and then moving west from there, that's roughly the Minnehaha Creek Watershed District. And the upper parts of the watershed actually include Lake Minnetonka, which is a pretty iconic water body for the region. And then flowing from Lake Minnetonka is Minnehaha Creek. And so Minnehaha Creek experiences periodic flooding, certainly, and for instance, in 2014, there was extensive flooding, which I think Ned's going to show in a little bit, some of that precipitation. But this area around here, if you can see the cursor, was an area that flooded particularly bad. There's a golf course here, which flooded out and remained flooded for so long that they've actually now abandoned that use and are looking at other ways to use that land more wisely. And so, because obviously it's not being profitable. There's a hospital upstream. There's an extensive restoration in this area, and I'm just kind of moving up the creek. And then it also hits residential areas that are, there's certainly single-family homes, also some apartments. This area in particular of the whole district is actually, other than Minneapolis itself, is an area with a fairly high minority population, quite a few underserved audiences in this region. So socially, this is an area that certainly can't always afford to manage the risk that they're experiencing. And based on the work, we've shown and we actually can see in real world that this area is, the risk of flooding is great here.
So I'm going to build off that point and drape onto this map the Social Vulnerability Index, which is something that Susan Cutter, I believe, developed out of University of South Carolina. It's a multivariate analysis of census data and demographics and various information about social conditions. And you can see census block by census block the relative degree of vulnerability. This would be low, moderate, high, and highest. And we were talking before the webinar, and Leslie was pointing out this is an area, an underserved population that is vulnerable due to lack of access to transportation and adaptation capacity. So we're layering into the Climate Explorer a capacity to look at climate information, social information, and begin developing a conversation with stakeholders about what are the sensitivities and adaptive capacities. We also can lay onto this map information about the weather history, or in other words, the climate of the region. So here I have maps that are interactive that allow me to zoom back in time and look at climate histories, and you can see here in green the average high and low for this area for temperature, and the blue bars represent the daily highs and lows that are actually observed on a given day. So you can see trends as well as long-term histories of data. Down here at the bottom, we're looking at precipitation, and you can see dry years and wet years. So 2014 was a very wet year. In fact, one of the events that really spurred Leslie and her colleagues into action was this spring of 2014 massive rain event. You see this jump in the hiatal curve here. All of these are massive rain events where you see a big jump in the precipitation accumulated through the year. Those are big storms, and you can see this was a very wet year, way above average. So this Climate Explorer allows you to interrogate historical data to facilitate conversations about what are your climate hazards. And returning again, this is exploring climate threats. We provide capacity to share this information. So if I were to copy this link and send it out to the entire group right now, you could, I'm going to do that. I don't think I can. I'll invite another panelist to share that link with the rest of the group, and they can click on it and see this graph for themselves. We also have the Climate Explorer that allows you to look at downscaled climate information for your area of interest. If we go to Hennepin County in Minnesota, we can pull up custom graphics that come from downscaled climate information. We'll start with mean daily maximum temperature on an annual basis, and you're looking here now at several layers of information. I'm going to just simplify the presentation for a moment and zoom into the historical period. So what you're seeing here is a reconstruction of the historical period from models, and I'll lay over that the observed record. So you can see this virtual line through the middle is the average from 1960 to 1989 for temperature, which is 55 degrees Fahrenheit roughly, and any deviation below that shows a year with lower than average temperature, and a deviation above higher than average. And you can see there's not a lot of trend in this line, maybe more amplitude in the line, but in general the observed record fits within the envelope of the model reconstructed using the downscaled climate projections methodology. So that gives you some degree of confidence that the model performs well, so that we could move into a forward-looking mode of using the models and look at a low emission scenario. This is RCP 4.5, essentially putting 4.5 1-watt light bulbs on every square meter of Earth. And you can see what the impact, if these downscale climate projections are a good representation of what happens. You can see that towards the end of the century, we'd expect a median increase of about 6 degrees Fahrenheit for Hennepin County. And that's for the low emissions, which is actually a middle emission scenario, 4.5. Here's RCP 8.5. So this is 4 watts per meter squared more energy over the whole planet. And you can see that's more than a 10-degree Fahrenheit change in the maximum daily temperature. So that's useful information for communicating with your colleagues. And if you find it a graph here that you like, you can just download it by clicking on this image button, and there you go. You've got an image you can pick up and use in another context just by clicking that button. You can also download the data. You can get the observed record, the historical modeled, or the projected data, and use those data yourself in CSV format. So this is a very simple interface to a lot of fairly complex data. You'll get every model making up this envelope. You won't get this median line. We've calculated that for you. But you'll be able to work with, use, and understand these data yourself. Note, though, that there's quite a lot of parameters in here. We give you monthly. We show you how the monthly curves would change over time. So you can see how that might affect, you know, how temperature envelopes will change over time on a monthly or a seasonal basis. You can look at minimum temperature, which if you live in Minnesota, you care about. If that minimum temperature is creeping up and you have less and less ice pack, it's really going to change, you know, everything from fishing to skiing to phenology of whatever crops you have, whether it's cherries or what have you. So minimum temperature is a really important parameter. Here in the southeastern United States, minimum temperature is increasing much faster than maximum temperature. We also have days above 95 degrees and days below freezing. So you can see projections show many fewer days below freezing out toward the end of the century. It's a really powerful tool. We also provide precipitation data, thresholded for you, as well as heating degree days and cooling degree days. So look how much less heat you'll need in the future. I mean, that's one thing people are going to save money on their heating bills. We also provide access to weather station data for that region down here. Every one of these graphs has associated with it a map that allows you to interrogate what the future could look like under 2 different scenarios. You can swipe this slider across, or you can jump into our full screen map interface to interrogate data yourself. This obviously is available for the entire continental United States, but you can zoom in anywhere and choose a county of interest and pull up a map directly from a graph directly from this map. And this interface works exactly the way I demonstrated a moment ago. So that, in brief, is the way the Climate Explorer is designed to work, what it does for you. I wanted to leave you with the idea that this is very much a part of a broader process that we want you to engage in through working with the Climate Resilience Toolkit before you move into further steps of doing vulnerability and risk analysis. I think that Leslie's case study was an excellent demonstration for us of how to conduct some of the further steps of looking at your risk and your costs and your options. But just know there are many other case studies for looking at similar issues, and you could find them just by searching for a keyword like culverts. You could come up with this case study, for example. You could find the National Stormwater Calculator from EPA and with explanatory videos. And so we encourage you to jump in and use the Climate Explorer as part of an integral part of step 1 of building resilience in your own location for assets that you care about. So thanks very much for your time.